right, kiddos, now that we have learned to write the equations of parallel and perpendicular lines, we're going to apply what we know to some actual real-world problems. This is going to be very handy to you when you take geometry, because this is the kind of thing you're going to have to do when you are doing proofs and trying to prove things geometrically using algebra when you get to geometry. So, our first question, we want to show that this image, QRST, is actually a parallelogram. So the first thing you need to ask yourself is, what do you know about parallelograms? Okay, parallelograms, first of all, they're four-sided figures. Well, yep, that one's four-sided. The second thing is that they have to have two pairs of parallel lines. Okay, opposite sides have to be parallel in a parallelogram, otherwise it's not a parallelogram. So this QT and RS have to be parallel, and TS and QR also have to be parallel. So we're going to have to prove that they are parallel. What do you know about parallel lines? Hopefully you remember that parallel lines have the same slope. So what I really need to do is check to make sure that this line QT and this line RS have the same slope. So I want to find the slope of QT. So that's the first thing I'm going to do. I'm going to find two pretty points. So here is one and here is one. Look, they even labeled them for us. Draw my right angle. That's a really bad right angle, but you get the point. And we're going to count our rides over our run. So I went up 1, 2, 3, 4, and over 1, 2, 3. So my slope for QT is going to be 4 over 3. In order for this to be parallel to QT, the slope for RS also has to be 4/3. So they've marked two pretty points for us. So I'm going to do the same thing. I'm going to draw my right angle up and over, and I'm going to count. The reason I drew it up right here instead of going like this on this side is because it makes it easier to count. My line's going up, my right angle should go up. So I'm going to count again. I went up 1, 2, 3, 4, and over 1, 2, 3. Well, looky there. They have the same slope. Their y-intercepts are unimportant right now because you can see that they are not in the same place. They don't touch each other. So all that we are worried about is their slopes, and they have the same slope. So what I have just proven is that QT is parallel to RS, and I know that because their slopes are the same. Now, I'm going to do the same thing, but I've got to now check QR and ST. I will tell you, I've put these lovely little graphs on Edline for you so that you can go pull them off if you need them, just so you know. I should have said that at the beginning, but now you know. They're on Edline. So now I'm going to check QR and ST. So we're going to find the slope of QR. Well, I need two pretty points, and they're so nice, they have labeled them for me. This line decreases, so I'm going to draw my right angle down and count. So to get from Q to R, it looks like I went down 1 and over 2, so it has a slope of -1/2. So far, so good. Let's now find the slope of segment TS. Do the same thing. Draw your right angle, and let's check it. I went down 1 and over 2, so it has a slope of -1/2 as well. So what I just proved, because they have the same slope, and it's obvious that their y-intercepts are going to be different, they have the same slope, so what I now know is that QR is also parallel to TS. Since these two segments here are parallel and these two segments here are parallel, then it really is a parallelogram, and I showed that by proving that the sides were parallel. And I did that because I know slopes have to be the same. Okay, so now let's do another one. We now want to show that triangle ABC is a right angle. So we want to prove that there really is a 90-degree angle right here. Okay? In order for there to be a 90-degree angle right here, what I should remember is that that means that segment AB and segment BC have to be perpendicular, because the only way two lines can meet and make a 90-degree angle is to be perpendicular. What you should remember about perpendicular slopes is that they are opposite reciprocals. So we're going to do the same thing. We're going to check the slopes of AB and BC and see if they really are opposite reciprocals, and so that will prove they're perpendicular, which means yes, really is going to be a right triangle. Okay? This side is unimportant, because in order to be a right triangle, I just got to have that 90-degree angle, so I got to prove these are perpendicular. So let's find the slope of segment AB. So the slope of segment AB, they've even done the pleasure of marking two pretty points for us. we're going to draw our right angle, and we're going to count. I went down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So the slope of segment AB is negative 4 over 6, which simplifies to negative 2 over 3. And if you look, if I go down 2 and over 3, there's a point on the line. So that's my slope for segment AB. In order for this to be perpendicular, segment BC needs to have a positive slope so that they are opposites, and it needs to be the reciprocal, so it better be 3 over 2. So let's check the slope for segment BC. I have two pretty points here and here. I'm going to draw my right angle, and I'm going to count. I went up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. And so my slope is 6 over 4, which simplifies to 3 over 2. I can check to see they are opposites. They are reciprocals, which tells me they're perpendicular. But we're going to do one more test to be sure. If you'll remember, if I take the slopes of two perpendicular lines and multiply them, the answer should be negative 1. If it's not negative 1, they're not really perpendicular. So let's multiply. Negative 2 times 3 is negative 6. 3 times 2 is positive 6. That simplifies to negative 1. Yep, they're perpendicular. So yes, that really is a right angle. So yay, I've shown that ABC is a right triangle because I proved that there really is a right angle there because those are perpendicular. Okay. Now, let's do this very last one. I want to write an equation of a line that is parallel to the x-axis and that is 5 units down from the x-axis. So if you think about this, okay, if this is my grid, and this is the x-axis and this is the y-axis, well, what kind of line does the x-axis make? The x-axis makes a horizontal line. And the equation of the x-axis, since it is a horizontal line, is just going to be y equals 0, because right here on the x-axis, no matter where you are, that's what y is going to equal. It's going to be 0. Right here it's 0, and at any other point on there, y is going to be 0. I need a line that's parallel to this, so it's also going to be y equals, but it has to be 5 units down. So it has to be from the x-axis down 5 units. That means I went down 1, 2, 3, 4, 5. Well, if I count that, that's at negative 5 because I went in the downward direction. So the equation of a line parallel to the x-axis, 5 units down, is y equals negative 5. Okay, that is applications of parallel and perpendicular. That's some stuff that, I mean, it's going to be useful to you when you get to geometry. We will practice this tomorrow, and I will see you then.